Hi, everyone. Thank you so much for joining us today for this session. We'll probably wait for a couple more minutes for more people to join in for the call before we actually start. So do please wait for a while. So it's approximately 3:05, and I think we should start. So thank you so much, everyone, for joining us today in the first of the Elsevier Publishing Workshop Series in 2021. The topic for today will be going beyond the fundamentals of journal publishing, and we'll be speaking specifically on the reproducibility in research. We have with us here two esteemed speakers, Dr. Martin Primera and Dr. Daniel Stamler. So Martin will be joining us subsequently in the session. He is the director of the Center for the Advanced Functional Nanobots, and he's also a distinguished professor of chemistry at the University of Chemistry and Technology in Prague. He joined Nanyang Technological University in Singapore, and he's currently a tenured associate professor for almost a decade. Daniel Stamler works in the Elsevier's Berlin office in Germany, and he manages a portfolio of materials engineering journals, which includes the Acta Materialia journals, a number of other well-established materials engineering journals, and Hardware X. He joined Elsevier in 2015, and he has been around with us for the past 6 years. So in today's agenda, what we'll be talking about will be a publisher perspective with Daniel. He will be sharing a reproducibility in scientific publishing. He'll talk about the different concepts of reproducibility, an overview on reproducibility, other research elements, as well as additional details and resources. Martin will be talking about case studies on reproducibility, as well as best practices, and we'll sum it up with a Q&A panel discussion. You can see on the top of your Zoom bar, there's a Q&A chat. If you have any pressing questions which you would like us to address, please type in your questions and we'll do our best to ask the questions that you have put up or to discuss this in the panel itself subsequently. So before we carry on, a couple of housekeeping rules. If you have any questions, do use the Q&A feature in Zoom. We have a couple of our colleagues here who will be able to address questions that you have raised in Thai or Bahasa Indonesia or Bahasa Melayu. So if you feel more comfortable communicating in your native language, please feel free to do so, and we'll do our best to address it. The questions will be addressed after the presentation. And if you wait to the end of the session, we'll be sharing with you a couple of links where you can sign up for a certificate. This entire session will be recorded and we'll share it with you over Zoom as well. Last but not least, if you have any problems with your audio, you can try refreshing or logging off and on again. So without further ado, I'll pass the mic over to you, Daniel. Over to you.
Thank you very much, Nicholas. And hi, everyone. Thanks for having me. And let me just put up my screen. All right, so I'm trying something new here, as you can see. So I'm projecting myself into the slide to give this a little extra kick this morning. For me, at least, that is. For you, it's the afternoon. And thanks for making time again and joining me to listen to Going Beyond the Fundamentals of Publishing and of Journal Publishing. And we're talking today about the reproducibility in research. Thank you for the kind introduction, Nicholas. I'm Daniel Stemler, and let me just see, 1 second here. All right, so a little bit about myself. So this is where I live, up there, here, there, you can see it. This is the country of Germany, and I live in Berlin since 2010. I have a little bit about my background. I have a diploma in public health and a PhD in educational science. I am with Elsevier since January 2015, and I am a managing publisher of broad materials, engineering and science journals, which include the Acta Materialia series. So there's Materialia, Acta Biomaterialia, Acta Materialia, and Scripta Materialia. And there is as well, I'm also the managing publisher for Materials Today, the flagship journal of the Materials Today family of journals. And so just a very tiny little bit about scholarly publishing today, how it looks like. So out there, you might have recognized this already yourself. There's over 5,000 science, technology, and medicine publishers. Large like Elsevier, Wiley, Springer, and smaller ones that you might not be aware that are very niche and for certain areas. So there's around about 22,000 peer-reviewed journals out there. And I stress here peer-reviewed because there are some journals out there that are considered predatory journals published by predatory publishers, which don't follow the publishing ethics and rules that the more serious and bigger publishers are put in place to ensure reproducibility, for instance. So, and there's a whole bunch of articles. These number here, the 3 million, might not be 100% correct anymore because we've seen a really big increase, for instance, over the past year due to the corona pandemic, and a lot of researchers having to stay at home and therefore also having time to finish analyzing data sets that they had or manuscripts that might have laid in their drawers and they could finish up. So I just wanted to show you a tiny little bit. So this is a little bit crooked here because it seems the animation is not really coming through. Anyways, so this is the publishing cycle. So basically what publishers do, and I read this out loud to make this a little bit more bearable here. So we solicit and reject submissions, and so 30 to 60%, that is, are being basically rejected by editors. It depends on the journal, as you can imagine. A high-ranked, high-impact journal like Materials Today has a rejection rate of well above 90. So then what comes after the submission, we manage the peer review process. And there's approximately 560,000 peer reviews that are being done here at Elsevier per year. And then this is, oh gosh, this is really hard to read. We edit and prepare the articles to be accepted then in the end stage. And these are roughly 370,000 a year, which, as I mentioned before, is more now due to last year's impact that we all, through the pandemic, that we all had to experience. So, and then of course, these need to go into the production and need to be made available. So right now on Science Direct, we are well above 12.6 million articles. I think it's much more than that, but who counts? We're in the millions. And just to give you an idea, to put everything online and make it available for everyone to read and to download, there's over 700 million downloads by 11 million researchers in 120 countries every year. So it's a tremendous amount that is being downloaded, read, and digested by all the researchers in the world. All right, so very quickly, what actually is the role of a publisher? So first of all, we register all accepted and published manuscripts. We gave it an official timestamp, which basically means it is recorded and saved and kept a record of until the end of time. Then there's a certification because we assure that peer review has been performed, and by that showing that the results are valid and the integrity of the submission that is being published. Then, as I mentioned, the dissemination, provide a medium for discovery and findings to be shared. This is, in our case, Science Direct. And preservation, so preserving the minutes and records of science for the posterity. As I said before, saving it until the end of time. And also, we're always looking for innovative tools and multimedia enhancements to connect other resources to make the user experience as exciting as it can be. And then, as you can see, there, Elsevier has been founded way, way back. As you can see, this was our old logo. And actually, in the 19th century, you see the logo became of what you might be aware of today. And then you see along the lines of all the different things that happen and that have been developed with the latest. So you see Materials Today has been launched over here in 1998 or 1999, I'm not 100% sure. Then the Scopus database, here, Science Direct. So just to point this out, that this came, so you can see how in the late 90s, early 2000s, the digitization, the internet had an impact on many of us, including the publishing industry, and therefore moving things online. Then Mendeley, you might be aware of, is a researcher network, also has a freely available reference manager that you can download and use your software with. Then SSRM, and then Eris is the company that we recently acquired, which runs Editorial Manager, the publishing platform that we use to manage all the submissions, the publication, peer review process, and then in the end, once it's accepted, then it goes into the production system. So all of that is being handled by Editorial Manager. All right, that a little bit about the history, and this continues on. And so here we go. So 1998 it was. Materials Today was launched. So I'm the manager, the publishing manager of Materials Today. It has a site score of 26.416 and impact factor, and site score is 31.1. So Materials Today is the flagship journal of the Materials Today family. And it is dedicated to cover the most innovative, cutting edge and influential work of broad interest to the material science community. And the editors welcome all comprehensive articles and short communications reporting about breakthrough discoveries and major, and this is really the emphasis, major technical achievements, as well as review articles from established leaders in engaging and rapidly developing fields within material science and related disciplines. And to show you a little bit more, so starting in 2014, a new collection of journals was developed to basically span the field of materials journals. And you can see here behind me, let me move myself out of the way so that you can see this better. Isn't that fabulous? So now I just need to orient myself and make sure that I point into the right direction. So over here, you see all of the journals that have been developed. And so in 2020, just with these that you see here, with the 11 journals that are here on the right-hand side, we published over 2,000 articles, and this excludes the proceedings journal. So basically it's 10 journals published, over 2,000 articles. And Martin, who will be joining us later today, is, let me just move myself again out of the way, is the, here we go, is the editor-in-chief of Applied Materials Today, which was launched in 2015, and it has an impact factor of 8.352. We expect this impact factor to rise again once the new, the new impact factor numbers have been released. That should be coming out any day now. So everybody's waiting for the new impact factor numbers to come out. All right, so as you can see, the Materials Today family is expanding and bringing together many, many different disciplines in the materials science area. So this is just a variety that you can see here that we have. And we're always looking for new opportunities to give researchers the outlets for their publications that they're looking for and that they're seeking. All right, so the Materials Today family provides authors and readers with a comprehensive coverage across the material science and spanning from groundbreaking discoveries to highly specialized research. So as you can imagine, there's broad scope journals where a lot of different disciplines are being published in. And then there are very niche ones, which are highly specialized, publishing very highly specialized research. And with this family, we are hoping to offer an exceptional diversity. And with that comes our ambition of high quality peer review, rapid publication, and ensuring that maximum visibility and the widest choice is being delivered to the people who are seeking to publish with us. So, and beyond the journals, just very briefly to mention, are many conferences that take place in material science. So just to mention the hybrid conference, which will be taking place in October 2022, and the upcoming conference of Nano Today in Guangzhou, China, in November of this year. So this is just, and then of course, there's also Diamond and Carbon Conference. So Diamond and Carbon Materials Conference. This one is online, just in case you're interested in these topics. All right, and of course, there's also books that are being published under the Materials Today brand, and this is just an example here of Quantum Approach to Alloy Design, or spintronic 2D materials that you can read up about, so the fundamentals and applications. So this is very close to our hearts here at Elsevier, and in particular, also at the physical science team that I'm in, and the material science team. So last year, for the very first time, we gave out the Materials Today Agent of Change Award, and we offered two $10,000 US grants to support the diversity initiatives within the material science community. And here you see the lucky winners. One from Harvard University, the Woman Plus of Color Project. And on the right-hand side, you see the professors here making professional role confidence a key part of educating the next generation of material scientists. And we will be doing this again this year. So we're going to have another round of nominations. So if you see that coming up, feel free to subscribe on our materialstoday.com website to the newsletter over there. And then you will read this announcement of this coming out, and then we're asking for nominations. And if you know of anyone that you think is an agent of change in the material science community, we very, very, very much appreciate you bringing this to us and letting us know about it, because without you, we will not know about it. And that would be, we actually have to say like a shame, because we would like to take that into consideration. And on the right-hand side of the slide, you see the Materials Today Rising Star Awards. This is an award that has been given out to sort of kind of younger researchers that are rising stars in the field. And this has been given out in 2019, and we're in the process of looking through the nominations for 2020, and we'll announce a new Rising Star award later on. Also, there's different journals who have these Rising Stars awards. Computational Material Science, for instance, just finished one of their rounds, and most likely they will do another. So keep an eye out. Again, subscribe to the newsletter of materialstoday.com on the website, and then you will see these nominations being announced there. And then, yes, you can self-nominate yourself if. Or you can ask someone to do that for you. Either or, it's all fine. So just pointing that out. And yes, and there's also a prize money behind the Rising Star Award. Okay, and as you can see here, just another number. There's in all of these journals that we have, that we show, that we publish, there's over 300 editors that are working with us, and there's over 35,000 articles per year that are being published in these journals. And yeah, with my fabulous colleagues, we manage the behind the scenes, so to speak, to enable editors to do their work and for authors to publish their articles yeah, in one of these journals. So Materials Today, what is important to us is basically that we work together across the journals. So we have a shared policy, for instance, on preprints and data sharing. We have a shared platform for submissions and also to read the published articles on Science Direct. The editorial teams are linked with each other. As I mentioned on the slide before, we have linked awards. Also, the conferences are linked with each other. We have cross-journal special issues. I have an example later for you. And what we also offer is a service to our authors that they can make use of. It's called an article transfer service. If an editor, for whatever reason, should decide that the article that you submitted to the journal is not suitable for whatever reason, then they will be able to offer you a transfer into another journal that is more suitable. And by doing that, you don't need to resubmit your paper. You just, by a click of a link and a button afterwards, you can basically submit your paper to another journal that has been suggested to you. All right, so what does it do? It reduces the time to publication, because with this offer that you receive from the article transfer service, it's, as I said, it's just a click of a button. You don't need to go to another submission platform and re-upload everything and fill out all the information, details of the authors and co-authors. It also reduces the referee fatigue, because what is being done, we ask reviewers when they review a paper to agree that the review can be also transferred with the manuscript, should an author agree to transfer it to a new journal. And therefore, it also reduces the editorial workload, because some of the editors can suggest that the paper is being accepted at the receiver journal, the journal that the submission is being transferred into, and therefore it gives the editor a pretty good judgment already, a judgment call from the previous editor to accept this paper. So all of these things are being put into place with the article transfer service that we offer. All right, so there's different, and just to round this up, there's different ways on how an article transfer can happen. So there's one that is a transfer pre-review. So an article is offered transfer before it's being peer-reviewed. That means that the offered transfer has no guarantee of how the article will be treated at the receiver journal. So because it needs to be looked at and eventually being sent out for peer review. And then there's a transfer post-review. That means an article has been transferred, and then it has been decided not to publish in the original journal, but it's being offered after peer review. Again, there's no guarantee of the article will be treated at the receiver. And then what I mentioned earlier is the transfer recommended accept. This is a very, very special type of post-review transfer, whereby acceptance is guaranteed. We have to take this in parentheses, following the transfer, which basically means the editor who offers the transfer tells the editor at the receiving journal that he should accept this paper into his journal. So what we see is just a very, very brief overview of the field overall of material science. What we see, as you can see, it's rising, the number of published articles, and we see this trend continuing. And there was actually a rather unusual, a significant spike in 2020. And again, this has to be contributed to the pandemic, that these high numbers are being recorded. Okay, very brief look at the publishing landscape. In 2019, there was an estimated 2.2 million subscription and 6 million gold open access articles published worldwide. So just to give you an example of how large or huge actually this market is. Subscription content is like 80% of the total of articles in 2019, and open access content makes for 20% of this. And then as you can see in this chart here above, you can see, so there's the gold OA is the dark blue over here. And then in hybrid journals, that is. So hybrid journal is a journal that publishes subscription and open access articles in one journal. And then there is a gold open access fully subsidized journals. Those are open access journals where the open access fee, where the publication is free to publish and free to read for everyone. And then there is the so-called gold OA articles in fully gold OA journals, which is this. I can't reach this high because then it's the one above. There's really light blue. And those are the number of articles that are published in gold OA journals. And as you can see, the biggest amount, the largest one is basically here. Move myself here. No, it's this way around. There, it's basically this big blue bar here that is that shows the subscription content of the journal. All right. So without moving right ahead, so there's different publishing models, as you might have guessed from what I was just alluding to in the different journal types that you can publish in. So there's two main routes for publishers to recoup the costs of publishing. So there's pay to read and pay to publish. So pay to read, basically the reader pays for the library of an institution to receive access to the research content. So that's basically what's written behind here, and published around the world. So basically the cost of publication is covered by the readers and typically in form of a subscription. And the other way is sort of kind of pay to publish. That means that individuals or institutions pay an APC, an article publication charge, upfront to cover the cost of publishing. And very important also to distinguish between honest publishing companies and predatory publishers. You will only be charged in a gold open access journal, or should you opt for an open access copyright license after your article is being accepted, not before, so after that is. Okay, so that is very important. So that's also down here highlighted again. Readers do not pay a subscription to access these articles. because of course, already the author has paid, or an institution, a funding body, could this be as well, or someone who subsidizes the article publication charge, and then it's free to read for everyone. Now we do see that some articles that are published under an open access copyright license are being downloaded more often because they're freely available, and also at times receive a higher citation rate. Not all, but we do see higher download rates for sure. Okay, and what is Elsevier actually doing to advancing the open access? So we've done many, many different things, and I don't want to like go over this slide too much. It's also available on our website. It's an infographic that I just wanted to show you. So just to give you an example, Elsevier signed many open access agreements with different countries among Norway, Sweden, France, Ireland, Qatar, Korea, Florida, and UC, the University of California, to basically ensure that the researchers that are working or studying at these institutions can read the content available or published by Elsevier, and also can publish their research as under an open access copyright license. So many things are being done, and we're very proud of our work, and we'll continue. There's many great innovations coming your way, so keep an eye out for those. Elsevier is always looking to advance the publishing world, if you so will, and how you can experience reading published articles. Okay, and then here's a selection of the open access journals in the Materials Today family. So we have MT Bio, Materials Today Advances, Giant, Carbon Trans, and then also Materials Design, just to name a few. Okay, and then open access beyond articles, and now we're diving basically into a little bit further into the topic of what can be done beyond just publishing an article. So helping authors to make their work discoverable, citable, comprehensible, and reproducible. So Elsevier developed a variety of research elements journals, as you can see. So there's Data in Brief, Method X, Hardware X, Software X, and then there is, Software Impacts. And these journals have been developed to help with researcher integrity and also with reproducibility. And what one can do is along a submission, you can also publish your data set in Data in Brief. You can publish the method that you used. You can publish a piece of hardware that you used, or even a piece of code that you wrote in Software X. And what happens is basically you put a sort of kind of a foot down and show everyone, so this method I used, or this piece of hardware I have developed, and you get another article that that can be cited and can also be linked to the original article that you published. Okay, we'll take a tiny little break. So these are some local flowers here in Germany, and this is my reminder to take a little sip of my water. All right. Okay, so I would like you to use the chat and answer the following question. So what do you think reproducibility, or why do you think reproducibility in science is important? So it would be great if you could just, there's no wrong answers here. There's so please use the chat and just type into the chat, why do you think reproducibility in science is important? So I'm just going to take a look. As you can see, I'm concentrating here on the screen. So I just want to see, very good one. Giovanni said to reduce an error. Then we see updating old findings. Thank you, Ari. Then to close a gap from Hong. And wow, this is like so fast. I can barely read all of this. For proper and true comparison can be done. Chen Sik, thank you. Munira says to update or upgrade, to improve science. I see here, wow, this is so many answers. This is great. To share your results, yes, to compare results across different disciplines. Let me see. Wow, I need to scroll up a little bit here because this goes way too fast. Wow, thank you for all these great answers. This is awesome. To publish new knowledge and trends in science. Thank you, Maris. Then George says to disseminate. Andy is saying bringing real impact. And let me see, I'm just going to go a little bit further down. To ensure results accuracy and its transparency. Yulita wrote this. So thank you so much. This is great. Keep them coming. I like this very much. Thank you. Okay. So when we look at the reproducibility, excuse me, the reproducibility issue, and take a look per subject discipline, then we see that the number of publications recorded in Scopus, this is until 2014, this study was done. You can read up about it. You see the reference right next to the Elsevier logo. In the title or abstract, at least one of the following expressions. So a search was done in Scopus until 2014. And as you can see, this is the number, the number of studies that were done. And you see that computer science is a very small fraction down here in this light orange. Then we have in engineering, we have the darker orange part. And then in chemistry, the light blue one. So this is, yeah, a very little number of articles that has been published, taking into consideration the largeness of the field that is out there. So, and a nature survey among roughly 1,600 scientists revealed that 90% of researchers actually think that there's a crisis in reproducibility. And 52%, that's the large red, the dark red part here in this circle, are actually calling this a very significant crisis. So the question is, why? So, and I found this other study by Baker, and they published this in 2016, and they looked like how much published work in your field is reproducible. And so we have the different fields up here, as you can see, and it's very interesting to see that in physics and engineering, as well as in chemistry, the people are most confident that the published work in their field is reproducible. You can see this as you look at these blue bar on the left corner. So you see 25% of respondents. That shows how many of them are confident. And then on the right-hand side, you see percent of published literature that is reproducible, predicted. And then if you go over to the left, then you see that these bars are pretty wide for physical engineering, chemistry. Those are the biggest parts. So that means that in physics and engineering, as well as in chemistry, researchers are pretty confident that their research is perceived reproducible. So, and what does this actually mean, reproducibility in scientific publishing? So basically, what it says, it's to make sure that research can be reproduced. And this is a massive step towards making it trustworthy and showing peers, funders, and the public that science can be trusted. And this is what has to be done to basically safeguard science. So nevertheless, replication studies are rarely published. And there's various reasons why this is the case or why this is happening. So in part is lack of a breakthrough in such a study, and therefore the little recognition that this also receives as relevant citation tend to go to the original paper. So if you just reproduce something and show that the work that has been done before was correct, and with all the information that you receive, you can reproduce the results. You can see that not many people are eager to do this because you don't get much recognition for this, even though this is very important to publish because, excuse me, because it shows that the research that was published originally was right, and it can be it can be shown that it was significant, that it was valid, and that is for some fields very important. And another reason is also related perception that journals and their editors are not interested in replication in replication studies. Let me just move this over here. And in particular, those studies that confirm previous results. So a lot of journals are just not interested because they want to publish high impact content, and sometimes it's seen as reproducible studies are not the way to do that. So reproducibility in scientific publishing, continuing on the topic, as Elsevier, as a leading publisher, is definitely working towards lowering this perceived barrier to publication. So, and we started to provide homes for research that promotes reproducibility. So for instance, you might have heard of Helion, welcomes good quality studies, no matter what the result is. So basically, even if you have non-significant results, or if there are no results at all, then still it has a chance to be published, because if you did a certain study and you didn't find any significant result, that's a result as well. It might not be as interesting, but it is a result as well. There's also a variety of virtual special issues that focus on reproducibility. For instance, one of them features replication studies in neuroscience, neurology, psychology, and psychiatry. And another one which with articles about the importance of reproducibility. And they're linked here, and we're going to make sure that you these links are going to be coming over to you. We're now working on new article types dedicated to replication studies, which will soon be available across a range of journals. And one of these type of articles is named registered reports, which is basically when you submit an article to a journal, you select that this is a registered report. So you basically send in your method and the introduction to your paper and what you're trying to do. You send this in, this is being peer reviewed, and then being said, yes, this all sounds legit, please go ahead. And with that, you get the assurance that once you receive the results, you basically then continue to write your paper and show the results and this discussion and conclusion that this will be published no matter what the results will be. All right, and then just to show you, and I mentioned this earlier, so there's a co-special issue on open hardware in research together with the Journal of Materials and Design. And so researchers will basically submit a research paper that has used an open source and homemade hardware, something that you build in the lab or at home as well. For a definition, what that means, you can visit this link that is showing here, to Materials and Design, and in parallel, they will submit a hardware paper to Hardware X. And this is what I mentioned before. So you get your original paper published in Materials and Design, and you have a co-submission in Hardware X where you describe the hardware that you, the open source homemade hardware that you developed. And then these two papers will be linked to each other, and anyone who visits the Materials and Design article will see right at the top that there is a further piece to this on Hardware X, and the same is for Hardware X readers. If they see this, they see, oh, there's an article that is attached to this. So this is basically one of the ways that how we try to ensure that reproducibility is being done. So you could also take, for instance, a piece of code, as I mentioned before, that you also publish, and then it makes it easier for others to reproduce your research results. So overall, when I started to prepare for this presentation, I can actually attest to the headline of this slide. So reproducibility in research, it's really taming a complex beast, because it is very, very complex. So there's three kinds of reproducibility, and this is not my own thinking. So this basically comes from John Ioannidis. He's a professor and co-director of the Meta Research Center at Stanford. And so he said the ability to reproduce research affects the credibility of science. And there's three ways of how, three kinds of reproducibility that he is stating or found out about. So it's the reproducibility of methods. So the ability to understand or repeat exactly as possible the experimental and computational procedures. So describing the method in your article or choosing to publish them in MethodX, one of the research element journals, to enable other researchers to really, to redo or to reproduce your research. Then the reproducibility of results, that's basically the ability to produce corroborating results in a new study, having followed the same experimental methods, and the reproducibility of inferences, to the making of knowledge claims of similar strength from a study replication. So these are the three types of reproducibility that are out there. All right, just give me 1 second here. Okay, sorry about that. So increase the proportion of true research findings. How can this be done? So how can one do this? So if you have the means, you can do a large-scale collaborative research. You can do this with others together. So I see that many people use the chat right here to connect with others on certain topics in their research. So yes, please do reach out and find collaborators, because together you can might be able to do a large-scale collaborative research study. You can adopt a replication culture. So basically making sure to enable the inclined reader of your research that he is able to reproduce this. Registration of studies, protocols, analysis, cost data sets, raw data results. Make sure that you upload those. So for instance, I give you an example in a little bit. So how you can upload data and make sure that your data set is citable. Also by registering those or publishing those in one of the research elements journals, also sharing your data, your protocols, your materials, your software and other tools is very important to do this. So, and reproducibility practices. So describing again what can be done, what kind of practices can be embedded to reproduce. Containment of conflict, sponsors and authors. I think that's very important. Always state in your article at the very end, were there any conflicts of interest? Who sponsored the study? Very important point. Use more appropriate statistical methods and make sure that others can follow up or follow through with them. Standardization of definition and analysis. We know that research lives from standardized operating procedures or statistical methods, definitions, and others. So yes, so that is very important point as well. And then let me see, what else do we have here? Improvement of study design standards. So also a very important point. So always look how have others done a study design, and then also improve existing study designs or use a standard to make it reproducible. Also, very much so improvements in peer review, reporting, and the dissemination of research. So that also peer reviewers who actually review articles that are being published are in the know and can apply their knowledge about reproducibility to the papers that they review. And of course, then also comes the dissemination of the results that are being published so that everybody can find out about them. So, and again, one other thing that can be done is better training for the scientific workforce in methods and statistical literacy. All right, and reusing research data is one of the points that I now picked out of all the possibilities that can be done to make research reproducible. And why did I do this? Because I very strongly believe that research data are the foundation on which scientific and medical knowledge is built. With the increased digitization of research, there are new possibilities to store and preserve research data. So capturing research results in digital form has many advantages. I just see that Martin joined. Hi, Martin. Good to see you. Hey.
Hello.
Hi. So reusing research data improves access, reuse, and again, the reproducibility. Also, if you can download a data set, you don't need to collect them yourself. That reduces costs. It saves resources, facilitates discoveries, fosters multidisciplinary research, and it promotes the integrity of research that is being published. So, and how do you make your data effective that you want to share is basically by 10 aspects of highly effective data I listed here. And let me move myself out of the way. Martin, I used this very, very cool feature here that I found out that I can project myself into the slides, as you can see. So number one is stored. So the first step in the hierarchy of research data needs is that data that have been acquired need to be stored. Then number two, once research data is stored, it needs to be preserved in a format independent manner or risk data obsolescence. Then it needs to be accessible. So even when data is stored and preserved, this doesn't necessarily mean it is automatically accessible. So, but both researchers and machines may want to access the data, for example, for meta-analysis or other kinds of reuse. And then on number four, you see discoverable, even if data are stored, preserved, and in principle accessible. This is not very worthwhile if the data cannot be discovered by others. So makes sense. Citable, one of the barriers to data sharing has been that it requires extra work from researchers for little reward. So you need to bring them into a format that is basically shareable. Data citation have the potential to change that because they can be easily incorporated into the current reward system based on article citation. So that's another one. They need to be comprehensible. So enable data to be reused. It needs to be clear which units of measures were used, how the data was collected, and which abbreviations and parameters are used. So data provenance is crucial for comprehension. You might have experienced this if you get a data set from a colleague or from another lab, and then there's something in there, and there's the description, the data set description of the different items and parameters is not there, then it's useless because you don't know what it has been used for, or what this particular number or field tells you. Then it needs to be reviewed. So while it's very common for research articles to be peer reviewed, this is still quite uncommon for research data. However, it's important, it's a very important step when it comes to quality control and trustworthiness of data. Then, here we come again, reproducibility of research results under number 8 is a very big concern for science. So the irreproducibility often originates from missing elements to research data, which are needed basically in order to achieve the same research results. So for example, resources, it's from the medical field, antibodies, model organisms, or even a piece of software, a piece of code, reported in the biomedical literature often lack sufficient detail to enable reproducibility or the reuse. And then coming up the before last, the key benefit for the wider research community of having research data being shared is the ability to reuse this data. So only when research data is sufficiently trustworthy and reproducible, will other researchers reuse the data. So that's a very, very important prerequisite here. And here at Elsevier, we believe that it is important to integrate these 9 aspects that you see above of highly effective research data. So for instance, data should be preserved so that it can be reused. To be citable, it needs to be accessible, but also in building systems for data reuse or data citations, the practices of current systems for storing and sharing data need to be taken into account. So, and these 9 layers, so 1 to 9, and 10th integration steps are intended as a guiding principle by which research data management practices can be ordered and checked, rather than as a prescription of a perfect performance. And I put a link in the resources at the end of the slide, because that's a lot to digest here for you to take a look at and to reread this if you want to make sure that you enable others to reuse the data that you have. And then last but not least, I'm just going to move myself out of the way again. One way to make sure that people can use your data is by storing your data sets and make your research data citable, uploading them to Mendeley Data. It's a very easy process. You basically create a data set, you upload your data, you excuse me, put a description in there, and then you will get a DOI number for your data set, which then you can cite and others can cite and download as well for further research if needed and wanted. So, and then I talked about this at many, many different times. I just want to point out, so Elsevier has a variety of research elements journals. These are all multidisciplinary because they focus on either data, method, hardware, software, and can be from various fields. They are peer reviewed, they're open access, and they publish short, digestible articles that describe one of these steps that are necessary to contribute to the reproducibility. All right, with that, I want to thank you for your attention. I picked one, which was data reuse, and there's many, many more. This is how you can get in touch. This is my email address. You can also find me on LinkedIn or Twitter. Feel free to contact me if you have any questions. And I think with that, we're going to welcome Martin to the stage.
Yes, so hello.
Hi. Well, thank you for joining, Martin. Very nice
hello.
to have you.
Thank you very much for the invitation.
Yeah, sure. And let me just see, because so maybe you can very briefly, Nicholas was so kind to introduce you in the very beginning. And I wanted to talk to you a little bit about, so from your standpoint of view, why is reproducibility important for you as the editor-in-chief and for the Applied Materials Today journal?
Well, in general, all the works are based on the previous works. I mean, we are not discovering wheel. We are always building our research on previous research, and therefore the previous research needs to be reliable, and that we can build on. Otherwise, if it's not reliable, that we are building on sand, and obviously our interpretation of our data are confused, that we are getting completely different results from the previous works, and we cannot really build on in general as a scientist. So that's the key point, to have reproducible data which we publish in our journal, and we publish as a scientist in general. So that's key question to the process of science, to have reproducible data. I always, and then if I go to more, I would say, personal level or my personal view of this, and I think this should apply, or it's applicable to whole science, is the data never lie. So the data are the data, as long as they are measured properly. The interpretation is our interpretation of the data, which may change over time as the knowledge progresses. And there's nothing to be ashamed that we have not a proper hypothesis at the start of the field. But the data are there, and if they are we can return to the data, we can say, well, the data were correct, but interpretation was not correct at that time, and we can improve the interpretation built on that. So always the data for me, if I go even step back from my editor-in-chief role to chief investigator of my group, I always say, whatever you get from the data, this is the truth, and this is the base. We build a hypothesis. Hypothesis can be wrong or correct, and it will be tested by the time and the other works, but the data needs to be reproducible. And now, if I go to the material science in general, because different fields have different ideas or different ways how to analyze and collect the data, and material science, I would say, is particular in the sense of field of chemistry. So I'm also a chemist. So in chemistry, you have a simple structure of molecule. It's either it is or it's not. And we have as chemists, we have very broad range of the tools to make sure that we got the molecule we got. And the point is that with materials, the materials are much more complex structures. And then we should, because you have different crystallinity, you can have impurities which you may not be even able to detect or to notice, and so on. And then in such case, as many characterization techniques as possible are needed to really prove that, or to show that you have fully characterized the material, even though they may not be necessary for your particle hypothesis, but it's very good to have very broad range of method to characterize the material, and then to of course make them available if possible, and so other people can eventually get to the data and build on that. So this is my view. So
No, perfect. Thank you so much. Yeah.
Daniel. So very long answer to simple question. Sorry, Daniel. Yeah.
No. That's perfect. That's really, really good. Hey, and then one question that I noted down before the workshop, when I prepared for the workshop, is, do you have an example in your research team how you make your discoveries reproducible for others? Like an example, if I may ask for an easy one. So if you can prioritize them so that others might be able to take this on. So maybe it's also something that you would wish others would do to make your job as an editor-in-chief a little bit easier. Is there something like that?
Yeah, I think in general, as I kind of mentioned in the previous question, answer, it's really, I mean, in my group, what we do, I kind of always push people to prove within, of course, the available means and whatever is available in the sense of collaborators and so on, to really fully characterize the materials, because maybe for your hypothesis, 2 characterization methods are enough. I mean, this is okay. It's clearly shown that it supports our hypothesis, fine, and our potential paper. But I'd like to see more characterization, and also I put in the final article more characterization that is necessary to prove the hypothesis. I often put it to supporting information just to have it there. For this reason, is supporting information can have 50 pages. And it's quite an invaluable resource of important data, maybe not the key for the hypothesis. So the key for the hypothesis are in the main text, but it's equally important to have those supporting information data. And then, of course, they are, well described what is there, but they are not key to support, key to prove the hypothesis. We put them into supporting information. And I think what I would wish is that people, as editor, people would make good use of the supporting information, and as the field of publishing evolves really rapidly in all forms, which is a great thing, different publishers try to facilitate it in different ways, and of course something works better than other. But in general, sharing or putting to support into information, the more data, then it's really necessary to prove the hypothesis is key, because often even for your own group, group members can go back to it, because students may leave, you may store the data in some data sets, but they are not available to new people because you don't share them. There are also lots of peculiarities. So please make use of supporting information. 50 pages, no problem. Of course, those supporting information, don't abuse it too much. I mean, in the sense that don't put 100 pages of raw data, because no referee will read it. And the referees should read also supporting information. This is also important, not to overload the burden, but put everything you have in organized manner to supporting information. That would be certainly something I'm looking forward. And I'm sure that this whole thing will evolve. We are putting data sets, sharing data sets. So I'm sure that in 10 years, we will be doing it quite differently, but for now, that would be wonderful.
Thank you so much. Thank you so much. So now that we know that reproducibility is a very important topic that we will be hearing lots and more about in the future. So I would like to turn to the Q&A part and have our listeners and people who are attending, thank you so much for sticking around and listening to what I had to say. So Nicholas, can you help us a bit walking us through the many questions that came in?
Yes, there's been approximately about 70 questions that have been fielded in. Let me shortlist a couple so we can tackle this step by step. So the first question is, how does reproducibility replicate the research and results? And in this case, how would you actually avoid plagiarism, but yet at the same time preserve the novelty while reproducing a similar research? So this question has come up in different forms. Primarily, how does reproducibility and novelty exist side by side? So that would be the first question.
Well, I think those are completely orthogonal things. I don't think that they kind of conflict at all. So the reproducibility and plagiarism, they're completely different things. Plagiarism is that you copy somebody's work, point. If I go back to material, so if I have graphite powder in my bottle and I do XRD analysis or any analysis, and I give you the same bottle and I publish this and you do your own, that is not plagiarism. It's the same material. It's your measurement. It should look almost the same. The data, I'm sure that the noise will be different, and so on, because it's new measurement. That's nothing. This is not plagiarism, point. So that's and you should get, unless something happened with graphite in the bottle, which is possible, you should get the same data. Except of the noise. So this is not plagiarism, and I don't think that this goes against each other at all. I mean, this is completely orthogonal thing. So if this answers the question, yeah. So that's the novelty is not. I mean, we are not. And I don't want to offend the people who ask, but the novelty, we are not in 19th or 18th century. Which anything which we discover and characterize, we can just publish. Okay, I found this rock. I characterize it, and it's new rock because nobody discovered this rock before. But the novelty is in idea. Okay, I have a graphite, but I want to show that, okay, graphite, if I do something, some treatment to the graphite, something happens. And this is how novel it is. It's up to the editor and referees to judge. But the novelty is in the idea, not the material I discovered. I mean, yeah, you can discover new material and as well, but it's very, very, it opens new fields like graphene. You do it once a decade, basically, yeah, or once several years. So that's fine to discover a new material as well. But this is not typical work. You don't have every paper on discovery of new material simply. So it's the idea behind. Why this material? What do you want to do? What do you want to prove? And of course the characterization. Yeah, that this is integral and part of it. And obviously the data should match with the previous data. It's like crystallography. This is not plagiarism if you get the same crystallography data. This is how the world works. Yeah. So if this answers the question.
I think it does. Daniel, do you have anything else that you'd like to add on to this?
I think Martin just answered this perfectly. So it's always good to have you on, Martin. You always make sure that this is answered correctly. Thank you so much. Yeah.
That's a great reply. Thank you for this very much, Martin. So the next question we have is, if we plan to reproduce our data, do we need to write the result based on new development or current trends? And what would be the suggestion if we were to use this approach for publication?
Wow, that was lots of new information on trends, and so I kind of didn't. I apologize. I didn't get exactly the question. I mean, I got the feeling, but I mean, I didn't get really the approach. So you measure the data, and should you interpret them on current trends, or what was the question actually?
So the question would be, if we want to reproduce our data, do we need to write the result based on new development or current trends?
Data and results. Okay, so I would again decouple those two things. The data are the data. Okay, so the data today in Prague, the sun when the sunrise was 5:30. Okay, this is the data. This is the data. I cannot do anything according to the current trends of the interpretation. This is the data. It's 5:30. Whatever the trend is, whether we like it or it's summer or winter, doesn't matter. It's the data. The results. Well, the results is I would say the data is the results of the measurement. So I would not decouple it. Interpretation is the other thing. So the data and the results, to me, the data, okay, I can measure temperature is the data. The results is result of some experiment I perform. I get something from the nature is the same thing for me. Is the data results. That's you. I mean, you cannot do anything with them because you get them. So whether the trend in the world is this one or that one doesn't influence at all your data or results. Of course, new equipment can do this, but I don't think that is the question. So the question is, what do you do with the data and results? Whether you interpret them according to new trends? Well, you should interpret them according the conclusion and the ideas they tell you. And of course, you can be creative, and there are new discoveries, and I would not call them trends, but new discoveries which are putting more light to the data, and then maybe we never thought about it. Then you may create new hypotheses which you didn't have 5 years ago, and this happens very often in the fields. But this doesn't do anything with the data, and always it's good to have even more data to support this new hypothesis. So let's imagine I revisit my old paper, 5 years old. I may look at the same data. If I reproduce with different eyes, I say, well, actually, maybe we never considered that. And maybe I need to have an additional experiment because to prove whether, this consideration, this additional different hypothesis is valid or not. Yeah. And we can perform another experiment. So, but shortly back, the data interpretation, it's up to you. What do you want to make out of it? What's the idea? If the data support or they don't support your hypothesis is equally valid, because I always tell, and this is my personal experience, not saying I have to imply to 1,000 people listening to us, but I always tell my students or postdocs, what you measure, this is the true, and quite often it's 50% of the time it's against my hypothesis. I mean, I have some hypothesis we go for the project, but very often it doesn't work the way I expect it. It goes quite often opposite. And I even say this is more valuable because we may have some unconscious bias, but it's completely opposite. But there must be some reason. I mean, the nature doesn't lie or make fun of us. What is the reason? And now this is really very interesting and important to dig for the reason. So I think it shouldn't be kind of influenced by trends. I don't, but you should really look, what is your hypothesis? What do you want to, what the data are telling you, and why you are performing the experiments? And very often they tell you different things that you expect to hear, not what you want to hear, but what you expect to hear. And it's completely fine. You follow the data. And you don't follow the trends very simply. So you follow the data. That's all.
Yeah, I think the only thing that comes to mind, and thank you for the weather analogy, is that basically that maybe a new model on how to interpret the data comes out. So there is, for instance, with the weather, there's 2 models. There's an American model on how to calculate weather prediction, and there's a European one. And depending on which model you use, you get sort of kind of slightly different forecast. So that would basically, if I say the data never lies, you said that, and it is what it is. So that those are the data or the results that you receive from the experiment or the data collection that you performed. And then you can, of course, apply different things. And if there is a new method that comes out, or a new tool, a new measurement, for lack of words, machine that can measure different frequencies, density, and whatnot, then you would sort of kind of follow the trend of technology to use to look at your data or to interpret your data in the end. But then the results that you get will then build up on the results that were there before. You're just taking a different angle at it, and you are being able to further analyze the data. And that would be the only way of how I can think of follow a trend could look like in this regard. So yeah.
Agreed, Daniel. Thank you.
Yeah.
Thanks, Martin and Daniel. I think that was actually a very good reply to the question. And I think, Daniel, this actually slightly overlaps with the next question, because someone was asking, is it permissible for research data that has been done and to be subsequently reproduced using the latest analytical method?
No, that's what we want. I mean, we want people to reuse a data set because it saves resources, as I said before, and time, and on all sorts of fronts. But then if you take a new approach on how to analyze the data, then yes, that is something one can do, of course. Yeah, there's no doubts about that. Yeah.
Yeah, I think that's just exactly going back to basic philosophy. You know, if you have the data, you share them with other researchers, they can revisit in 10, 20 years and you know, build on this. And yeah, completely agree with Daniel. Nothing about that.
Great. So another question would be, what is your take in the aspect of data privacy in terms of research participants, in terms of reusing research data?
Well, I think this is more political question to Daniel. I have, of course, my own personal or view of this, but maybe I would maybe ask the Daniel to reply, and then I will add something small.
Okay, Nicholas, can you repeat the question, because it seems like it's twofold. So, yeah.
So they want to know what our take in terms of data privacy of the research participants in terms of reusing research data.
Okay, so data privacy, and I'm guessing now that means probably from the people, or the people who are part of a study, I assume. And we do take data privacy very serious at Elsevier, because just imagine, and I'm going to use an extreme example here. Just imagine you're going to do a study on, and it's a far off from material science, but well, basically not, but you want to see what is the impact of a filter system that is being used at a nuclear power plant on water quality in a high density population. And you have basically, you have a randomized controlled trial, and you have maybe 1,000, 2,000 people, and they come in and you have to do the blood work, and you look at the toxic level of whatever, I'm making this up. So there you want to make sure that these people cannot be identified afterwards, because you might find things that someone has leukemia or whatever, some other form, some disease that you don't want for someone who gets a hold of the data set to basically backtrack and find that person, or basically make pretty much sure that they live in a certain area. And if we then call up some doctor offices, we could find out that there's only 5 people with these conditions. So you want to make sure that this is all, that data privacy is basically you try to anonymize the data so that no backtracking is possible. So in particular, think about in the medical field, In social studies, there's many ways where you don't want this to be tracked back to the person. And what we do is, so for instance, in the field of medicine, there's so-called case reports, where basically individual cases of some form of disease, some form of treatment, also rare diseases, which are very important to take to be looked at and researched on. So when someone submits a larger data set or a smaller one that has that has data in it that could make it trackable to a certain person, we ask for a statement that there is, if it's only one, or if it's a countable number, like so kind of 5, or it's a case report, or a multiple case reports, then we ask for that the author states towards us that he has an agreement signed by the patients that they are allowed to use their case and publish on it. So that's number one. And otherwise, so that's one of the things that with data privacy. And now you have to remind me of the second part of the question. Sorry, Nicholas, putting you on the spot here.
No worries. The second question would be, 1 second, sorry.
Yeah, no worries.
How would you be subsequently be able to reuse the research data?
Well, well, case reports you probably not reuse because it's a single, or it's like maybe up to 4 or 5 cases that are being described. So you probably won't reuse this. You might just, a maximum is you refer to them. But if the data is analyzed and anonymized, then you can reuse it by citing it, and then basically making sure where does the data come from, how did you receive it, and if somebody published the data with a DOI number and made them publicly available, then you can reuse them, but you just have to make sure that you state the source and where they originated from. That would be, I hope this answers the question. But Martin, please, I'm very interested in how your take on this would be, because you have a different perspective. Mine is like more from an educational medical perspective. So I'd be interested in to hear.
I think in general, thank you very much, Daniel. I think in general, it's the same, very similar or same view of what you just described. What can I just add is that in material science, again, that unless there are some sensitive studies which are related to things which cannot be published, then it's of course the question whether this whole thing can be published at all. I mean, you cannot say, well, I have XRD pattern, but I am prohibited to show you, because then it's basically against the whole philosophy of publishing. But yes, anonymized data, if there is any involvement of the names or things are, I mean, for material science, I would say this is norm, but I don't think that is huge problem for material science, but indeed for other studies, other fields, it needs to be taken care of. And I believe those fields have the appropriate measures to take care of. But if you have the data sets for materials characterization, you should publish them as they are, and obviously you need to make clear with your co-authors whether, if they are from other institutes, whether you are not publishing. I mean, you need to have agreement of everybody on publication anyway. So to me, what was said by Daniel, but I don't see that in material science as a huge problem. I can imagine that in social studies or medical studies, this is obviously something else.
Yeah, what comes to mind is also, I think some studies cannot be published because, so for instance, if you do some research on materials for the military, or if you do some research on nuclear materials, and so some things might not be publishable because of the, what's the right word here for this? Because it's for a lack of better words, it's too hot to publish. So because it's sort of kind of secret, and so I think that would be something, because I know that a lot of research is done sort of kind of for materials for the military or things like this. And then you maybe can be publishing parts of it, but you might not be able to give the data out because it's, yeah.
But I agree with that, and indeed, I myself had some military grants, but it's obviously written in the agreement. It is always written what is the procedure for publishing, and typically needs to, and it's very clearly written in the contract whether you need to have approval or. In such cases, and if you need approval, you just need to run it through the appropriate steps, which is part of your grant scheme, nothing to do with the publishers. But on the other hand, if you are, kind of prohibited to share some part of the data, it's up to the referees and editors say, well, this is not enough supported, and that's it's our right not to publish, because we cannot publish that saying, all the data are secret and this is the interpretation. So that's always balanced. But on the other hand, typically the industrial or military, but it can be in industrial research, you have in grant agreement, this is simply not to be published, and this is not even the deliverable of the grant. So the grants are not only for kind of basic research or publication direction, but it's for I would say even basic research for military cannot be published for some time, or industrial research also cannot be, but it's clearly written in the funding scheme, and you just follow that. But that not everything can be published and should be published simply.
Thanks a lot for your answers, because this actually ties in very well to the next couple of questions which came about. So basically they wanted to know, in terms of data for simulation models, is it limited in time? If it is allowed, how many years would this time limitation would be? And if there's a particular rule on how old research data can be reproduced for. So it all boils down to a timeline in terms of data sensitivity and what are the rules and permissions with regard to this.
So simulation data, so I mean, I'm a little bit missed that. So the question, for how long they need to make them available, or?
Yeah, to be available.
Well, I think that's also, maybe I will pass this to the yeah, but I mean, let's put it very simple from my perspective as editor. I will pass the more broader view of Elsevier to Daniel just in a second. But to me, if you are publishing peer-reviewed article, the data needs to be. I'm not talking about the raw data, but the data as part of the article needs to be available indefinitely. I mean, as long the hard drives on the servers work. So there's no limitation. Okay, after 5 years we kind of we take it out of this market. No, if this is part of the publication, should be here in 100 years. Yeah, and whether it's simulation data or measured data, that's for me. There is no other question. Another question is the raw data. Some journals like Nature Publishing House and other publishers as well, and some journals within the publishers require, some don't. 5 years availability of the raw data, I mean every measurement which is then interpreted. Not everything needs to be kind of. Sometimes you have some averages of you show the data with relative standard deviation, but you should store the raw data on which this is based for 5 years from the publication. So this is based on the publishers and the journals rules, and you need to read carefully. But talking about data sets which are part of the publication, that's, from me, my viewpoint, there's no question it needs to be 100 years, plus. Yeah. So that's, I pass to Daniel.
I'm in full agreement. If you publish your research and there is data attached to it, then it should be made available. And since, as I mentioned earlier, that is the publisher's job to give a timestamp to what has been published, that means until the end of time, this data should also be made available. And I think it's very important that you look for an opportunity to store your data somewhere where you know it will be available like that, so you can upload it in addition or as a supplement to the article that you publish with Elsevier. You can link to it. There's different data repositories that you can use to link to it. And the good thing is that you get a DOI number, and then also it's a citable item. So you also basically make sure that the data is connected to you as the one who collected it and made it available. And by doing so and making it available until the end of time, it gives others who might refer to it later a chance to revisit and see what were the results that you gathered from a certain experiment, and then what has changed over time, and or not, and which way was used to gather this data. So I think it's as Martin said, very much so until for hundreds and hundreds of years, the data should be made available.
I definitely agree with you on this. So another question that came up, and I think Daniel, when we were speaking about this initial session on reproducibility, we talk about reproducibility and replicability. So this question has now come up in the chat because someone wants to know the difference between reproducibility and replicability. Can I trouble you to clarify on this?
That's a very good question. You know what I need to do? I need to translate this into German. Otherwise, I will not be able to answer this question. Hold on 1 second. I need to, because okay.
If I may
yes, please.
by the definition which is you know in the dictionary. So reproducibility is that you should, I mean it's just really a term for particular thing. So reproducibility is something you should be able to reproduce it in your lab using the same equipment. So in 1 year you go to your lab, you have X-ray machine, you measure, you should get the same. Replicability is different team. So basically your team in Singapore or in Malaysia or Japan replicating my results. Yeah, reproducibility as a term is for my own lab, but this is according to the dictionary. So those words are your own lab, your own methodology, and then other lab their own methodology is replicability. Yeah, but quite often this is used in normal terms interchangeably. I don't follow the dictionary when I talk normally to audience, but I pass back to the Daniel and Elsevier.
No, Martin, thanks for saving me. While I'll pull up my dictionary here to look at it, and basically, it's replicability is meant to replicate something, and then if you look at reproducibility, it's basically to make it comparable. So to make it comparable to the so that you can compare them to the prior published results. So that would be the term that is given by the dictionary. So it's close enough, but there's a difference there, and we don't want to get deeper into it because I'm sure you could have an entire presentation of 45 minutes on the differences in these two, in the meaning of the two words. So.
Yep, got it. Because this was something which we talk about, and we also realized that it would be going down a rabbit hole as well. So another question that came up, do we always need to submit our supplementary data? And I think this is a good practice question. So I'll leave it to you.
This is like extreme. I'm sorry, yes, I will take the word. So this is extreme. Do we have to? I mean, you don't have to do anything in life. Okay, well, I guess you need to breathe, but otherwise your organism will kick in and will make you breathe. But do you have to? That's obviously answer no. But you may not get accepted paper. Referee may not be convinced, and so on. So I would put it. I would transfer the question to something which is kind of giving me opportunity to actually answer. Otherwise, than no. Yeah, one word. So I would say. You as a researcher, me as a researcher, not talking as editor, I want to prove my hypothesis. I don't have to do, but so to prove and to make the hypothesis solid and actually I personally, as a scientist, you need as much support as possible. And then I don't see any point not publishing the data or sharing the data with others in other form, then, you know, if I want to support my hypothesis, of course, I may, as I said in my first answer, I can decide, okay, this is not support, this is just additional data, I don't necessarily need it, it's characterization data to prove my hypothesis. I publish them personally anyway because I find it valuable, and valuable not only for outside community, but also for my team in the future, because you have this three-dimensional space plus time, and the time is also really changing. And if you remember, but maybe your group members, you know, are new and they like to access the data. So this is kind of something people forget. Okay, I don't want to share this. Well, you share this also with your group members, because most of the labs, they don't have kind of data sharing servers running for the group. You know, I mean, you do it with the team members, but in 5 years, typically it's very difficult. It's possible I have the data stored for my 20 years career, but I don't share it on daily basis with everybody. So if somebody asks, can I see the data from that paper 5 years ago? Sure, I have it, but it's typically not shared. So to me, it's very important to do it. But answer no, you don't have to. But then you may not get published, or your hypothesis you also can be weaker. So I see no point not publishing if you have them. And I think, as Daniel mentioned, I think it's something which is very important also for the people to, because you can now in the digital age, you know, I've even, you know, the journals which are 100 years old, and you have the table with the data, you know, you wonder why they, you know, they filled on typing machine those tables and then copied. Now you can assign the DOI, digital object identifier, to your data. I mean, what better can be? The data are assigned to you then. I mean, for history of the time, you know, I mean, you know, mankind. So this is something very unique, and I think couldn't have, I mean, this was not possible 20 years ago. So I'm actually very grateful for those developments in the literature, and I see no point not sharing. I mean, the only thing which can be wrong with the data, you fake them. Yeah, because I mean, this is really so then in such cases, it's kind of dangerous to share the fake data. I mean, be very straightforward. But if you measure them and they are honestly measured, but the interpretation changes in 10 years, this is very possible that nobody should put shame on you, because you use the data and the current knowledge, the best possible knowledge, to publish, and then through peer review, and the, you know, the interpretation or the knowledge of the humankind changed and improved, and then the data can be interpreted different way, but they are honestly measured, and no, you know, you should not be ashamed of data and point. So maybe I talk too much. I pass it to Daniel now.
No, it's perfect, Martin. Thank you. No, because one thing I just wanted to mention on this is, even if you don't share, if you decide not to share your data and you publish your research and it gets published, anyone can actually reach out to you and request the data from you, because that is because if it is published, it went through peer review, and then it's sort of kind of part of the scientific status of the knowledge in this field. And if someone wants to redo or look at your data, then as an author, he can send a request and you need to provide this. This is sort of kind of part of it. So then why not share it in the first place? Make it an alone standing citable item, and then you have another publication you can show. So I think that's up for you to decide. Yes, it is extra work. Yes, it is a hassle to go through and prepare the data set to make it available to others, but you will do the research, the subject area that you're working in, you do a very great favor to all of your colleagues and your peers.
Yeah, I agree. And also, I think you make also yourself favor, because in general, and this is, I mean, it's not ultimate decision in this way, but typically, you know, the referees or, you know, people like to, I mean, they're not your enemy. There are people trying to improve the paper interpretation and to see the possible holes in this. And typically they can be more convinced of hypotheses if there is more data. And then, of course, if you show to the referees, typically you need to, you know, they're publishable. So actually providing more data in organized manner, so actually people can go through, is beneficial for yourself as well, even in the short term, that actually getting published in you know, very competitive journals, because we just need to be sure that we are publishing, you know, well-supported research.
I think that's a great reply. Fantastic. I really thought that this was actually a good chance for you to share this information with the people who asked it, because it would actually really help them in terms of a best practice approach. So I'm going to backtrack one question before, remember when we're talking about reproducibility and replicability. So I think we maybe have dug up a can of worms here. So somewhat, not really can of worms, but we have really started going down the rabbit hole. So I'm going to take one part of this question, which would resonate with it. Someone asked if the experiment was done in, say, a country like Malaysia, where the weather is very hot and the result is positive. And let's say if they were to do this over in, say, London or another part of the world, and the results or the reagents would react differently. What do you think of this, and what do you make of this? Because is it reproducible? Or sorry, is it in this case replicable? And what would be the best way to approach it?
This is almost a question for lawyer. Yeah, that's yeah. I would keep it with lawyers, but yeah, I have actually some very short story on my colleagues. Well, it's my colleague, but my friends from Japan. Because Malaysia, Japan, the same of weather and humidity in some of the part of the years are not so different. Yeah. So the thing is that they are. But this is a very interesting story from the viewpoint that you, of course, I mean, you can even go to not kind of inorganic powder-like materials like, you know, calcium carbonate. It's very, very simple stuff. And this is typically hydrated. And if you have I go then to Japan, but you can transfer to Malaysia, Singapore. I stayed in Singapore for 8 years. If you have humid weather, then obviously there is more water trapped. So when you wait on just balances, it's you are waiting more water and less the material. Than if you calcinate, heat it, of course, loses the water. And if you make some stoichiometric mixture of two materials, then actually it's maybe not stoichiometric. You think it's stoichiometric, but it has lots of absorbed water. So actually, my colleague, he spent like 3 or 4 years to see that his results in summer, which is in Japan very humid, are different than from the winter. And he spent 3 years to figure out why his ceramics behave differently. And then because he was mixing several components, and he realized that it's because of the humidity involved. And actually was very interesting discovery from some phase, you know, other things. So basically, ideally you should you should make sure that that, you know, but it's obviously in Singapore you have the weather humid always. Yeah, this is challenging. Yeah, but yes, indeed those things can happen, but they basically, yeah, you should put all the information which is available. I will just maybe 2 more steps. I mean, I'm not lawyer, and I will pass this to Daniel as well, but as a scientist researcher, you put all available information in the paper. And obviously this for this reason, I always advocate in my group, but also in other groups, you need to have not 100% bulletproof. You need to have 200% bulletproof written manuscript, because exactly as you mentioned, there is always 10 to 20% variables which you don't even account for, like humidity. You just cannot imagine that it could influence your results. I mean, to me, it was kind of surprising for my colleague as well in Japan. But those 20%, if you have 100% bulletproof, then you have actually 80, and there is 20% whole. You need to have 200%, 150% bulletproof thing, then you can have margin of error. 20%, and you are still proving what you are proving. You understand? So I think indeed, you know, it needs to be replicable. But of course, there are things you cannot account. But if you know it takes water, you should do it in glass box. Point. You know, there's no excuse. Well, we have humid weather. Well, if we know it, if it is known, if it's not known in general in literature, doesn't mean that you are careless. You don't check. But if it's really not known, it's new material. Yeah, that's what it is. It's the current stage of the knowledge. But if it's known and you are careless, you don't go for glass box. Yeah, what can I say? It's poor practice. That's. I pass to Daniel to more lawyer-like answer.
Yeah, it's basically, thank you, Martin. So this is great. I love the story because this illustrates it. So in many studies, it's basically the things you control for. So just like write down everything that could have an influence, and that is part of your experiment or the methods there, the methods that you use and how you've done the experiment. And if the humidity was like this and this and this, then it would be good if you make this, if you're able and you control for it, then you write it down into your paper because it's part of it. So yeah, so that's basically my short answer for this, to this question.
Yeah, I thought it was a very salient question, given that you're currently in Germany and we are currently in Singapore. It makes perfect sense, right? Yeah.
We
So
finally got nice weather. Yeah. The humidity is rising.
it's raining in Singapore right now, so you can hear a little bit of thunder in the background.
Yeah, we'll never get to where you're at, I think. So
Not for the next 2 years.
Yeah.
All right. So I think you have addressed this slightly, but for more clarity, someone wants to know how can we specifically register our data sets, our table of specifications, and our analytical codes? You mentioned a little bit about DOIs. How would you go about doing this?
Oh, okay. Yeah, that's an easy one. So if you want your data set to have their own DOI, like it's in citable items, you can go to Mendeley. So you can upload it there. And then once you filled out everything, excuse me, and you uploaded it, then it gets a DOI, then it is a citable item. As far as I know, within Mendeley, it's not being peer reviewed. So it is a citable item, but it's not peer reviewed. So basically you store it there. And if you want your, so kind of you have a piece of like a code, a software, or you have a new method that you describe that you use, then you can co-submit. It's called a co-submission, or you submit it to one of the research elements journals that I mentioned before as an extra submission. And then upon acceptance, you let the editor know that this links to another paper, and then the so-called journal manager will make sure that these can be linked to each other so that people will know that this is there. And either or, if the method is published, then it is sort of kind of kept record of, and then you get a DOI because everything that is published gets a DOI. Yeah.
Got it. So another one that came about would be if authors did not reply or to provide a data set, how would you go about getting this data set? And another option from the other part of the lens would be, what is the best action to take if your data was being grabbed by other researchers? So the first would be, how does one obtain a data if it's not provided by the author? The other one would be, how do you react if your data was being obtained by other researchers, like in an illegal way?
Well, the legal,
for the ethical team, so I will pass this to Daniel.
I'll try my best here. So if someone reaches out and wants the data from you, then you're, so in good ethics of research, and you would actually share this and pass this on. So it's also a way of collaborating. So I wouldn't see this always as a threat. I would also see this as an opportunity to collaborate with someone, and I would just like ask. You can reach sort of kind of over to the other team and ask, why do they want it? What are they looking for? Depending on, of course, I know that there's competition between different laboratories. I'm aware. But nevertheless, it needs to be made available. So you should supply the data needed. And if necessary, you can put a contract around it and whatnot and have an agreement signed that they can use. So that's all up to you and your institution and the policy that's in place over there. And the second part of the question was, what if someone illegally got a hold of your data set? Then my first question would be, so if it's illegally, then the data, I'm assuming the data has not been published before, so it's not available. So, but somehow someone dropped a USB stick, I guess, somewhere so that someone got a hold of it. And that basically, the only way how to go about this is you can take legal action. If that's the only way, but this is beyond what the publisher is in charge of. So all ethics cases that come up have to do with what has been published. And if the data set never has been published, then we are not involved and we cannot get involved in this. That is something entirely up to you to make sure that your rights of the owner of this data set are being processed accordingly.
Got it.
Yes. So yeah, if I can just add to the first part, do you hear me? And then something disappeared. So to the first part, yes, I completely agree with the Daniel. But please note that sometimes the authors are just maybe not receiving the emails because it ends up in spam. So I typically believe that all the people are good people, and then it's just they don't necessarily always reply. It's not that because they like to hide something, but I always assume the good intention, and if I need data or needs to be provided, you can contact editor in the like last instance. Please, can you just ask the authors to provide the data? But personally, I never had to do this as author, but as a scientist. But I think it's you can ask author if not, then from different email address, and typically it works. And as Daniel pointed out, it may sometimes be needed to to negotiate away the data, or what extent the data are shared. But again, typically for this reason, I prefer people share what they can share at the first place, and there's no problems later. Yeah.
Thanks a lot for that. So in the meantime, I understand that some people would have to leave. So right now, what we are doing is we're sharing a couple of SurveyMonkey questions that you can scan and complete. And for those of you who are here, you would like to get a certificate, we will share with you the link and the code. You have to wait for the session to be over before you can actually redeem the code as well. All right, in the meantime, I do have a couple of last questions, which I think would be a good way to wrap up the session for today. So since Martin and Daniel are both here, so I think this is a good chance to talk about rejection rates, right? Not directly pertinent to reproducibility, but since you're here, you might as well tackle it. So we know that rejection rates in general are high, right? I'm not referring in any specific numbers pertaining to the journals at hand, but what would be a big reason for such high rejection rates? And as an author, what can you do to safeguard yourself or to minimize the risk of rejection? I know this is a completely different session as well, but since we have time, we might as well talk about it.
This is kind of that's a surprise question, but as an editor, I mean, if I may, Daniel, to start answering that. So to me, it's look. I would again approach it from the position of also author, and also that I was once in time I was starting research with my own group, and so I also had the trouble to to reach to, I would say, high impact factor journals, but I would also transfer the impact factor to impact. Actually, when I talk to my group now, I talk, okay, we need to look at the impact of our paper, not talking about the impact factor, how big impact this paper will have on the community, or this work, or this idea we are just discussing over the piece of paper, over coffee. We are not even having about the chemicals, but what impact to the world we will have with this, if this works. Of course, it may not work. And I think this this is very important question for you as a human being, as a scientist, because you are going to burn your and somebody's time for maybe half year or 3 years or 4 years on this project. So is this really a project worth of impact and pursuing, because you are burning your time and you will not get ever more time, as Steve Jobs said. I mean, the time is limited. Money can be unlimited, but the time is always going down of your life. So is it really worth the burn the time, and what is the impact? And then it's very simple. If the rejection rates are basically going back to the answer. So with higher impact, the probability or basically impact factor somehow in there's also, we can have 2 hours of discussion on bibliometry, but it's connected to the impact of the work. So typically higher impact factor journals, typically on average, publishing more impactful work, not only because they are in high impact factor, but they got there somehow as applied materials today. And we were just selecting the most impactful work. So this is also, if somebody asks me how do you increase impact factor of your journal? Well, I don't. Well, it increases itself because I look for the most impactful work to the field. And if you, as a young or senior, doesn't matter, junior, senior researcher or group leader, or produce impactful work that which is kind of bulletproof from the experimental point of view, there is really a very high chances to get published in high impact factor journal as ours. And I think that's not always, you know, when you are young, you think that, oh, well, when you are young, I'm older, but sometimes you feel this is so genius work, you know. I feel it about every paper I have, but not everybody feels that. And sometimes I have to say, well, you know, I was wrong. Maybe this is not so genius work, and maybe that's not so novel, and you know, it hurts. And I'm author, I publish a lot, but this is life. So yeah, that's all. So try to be, you know, provide the biggest impact, and don't take it personally. I mean, sometimes we just misjudge, you know, our view is still unique, wonderful work, but maybe not in eyes of others. So, you know, I wouldn't say there's something wrong with the work or something wrong with you. It's just different point of view, and that's I think my take on this. But Daniel, if you like to answer this, if you have still that.
No, I think yeah, I know. No, I think you answered it absolutely right. So there's not much to add from my end, I think. Yeah, no, just like, thank you, Martin. So nothing comes to mind that I could add.
Thanks a lot for this, Martin. I think you have summarized it actually perfectly well. I think at the end of the day, it's nothing personal. If there's a rejection that occurs, I think one should just be very constructive about it. And I think this has been a very constructive workshop. It's approximately about almost 5 p.m. We have fielded approximately almost a total of 100 questions in the Q&A chat box and in the panel. And I think this has been very productive. So Martin, Daniel, thank you so much for taking your time here and spending this past couple of hours sharing with us. It's been an absolute pleasure having you here. Thank you.
Yeah, thanks for having us.
Thank you very much for organizing this wonderful meeting, and thank you for everybody to joining. And yeah, you know, we are looking forward to meet you next time, and also to get your, you know, impactful papers. And please just note the last comment. You know, the referees near editor are, you know, trying to hurt you. That just try to help you. And when sometimes the comments from the referees are really impactful to me in the sense of I never thought about it, and I can actually get completely inspired by the answers of the referee. So please do read the answers carefully and try to improve your work next time. And I do it, you know, all the time. And actually, this was maybe one of the ways I took it as a constructive criticism, and I believe I improved. So please take it from me. Thank you very much.
Thank you, Martin.
Thank you, Martin. Thank you, Daniel. Thank you, everyone. Do stay safe, be healthy. We see you all soon. Thank you.
Bye-bye.
Bye-bye.